Hello friends, I'm Engineer Nasir from NC Engineering and Technology. Now we will study how to design domestic hot water recirculation system for a high-rise building. It is the hot water supply riser diagram for a 24-story building where we have electric water heater at the basement and it is supplying hot water to the building through a main at the basement and through 14 number of risers. The size of hot water supply main start from 4-inch diameter and it is going decreasing as it is distributing hot water to more and more risers. At the end it became of 2-inch diameter. Some riser started ground floor of 2.5-inch diameter, one riser 3-inch, at the end two riser 2-inch, one riser 1.5 inch. As we go up in the riser, the size of hot water supply riser decreases and at top floor for some riser it became 1.25 inch and for some riser it became 1 inch. To design the hot water recirculation system, first of all we need to calculate the heat loss in each pipe segment of hot water supply piping network. For the calculation purpose, we make an Excel sheet. Here the first column is for pipe segment, the second column is showing the pipe diameter and the third column is showing the pipe segment length. For pipe segment 1, between electric water heater and riser number 1, the pipe size is 4 inch and its length is 20 feet. Similarly, the pipe segment between last two riser, the pipe size is 2 inch and its length is 25 feet. Similarly, we complete the table for all pipe segment in all risers. The floor height is 11 feet and the pipe segment in the top floor is 9 feet. To calculate the heat loss in each pipe segment, first we will select the heat loss rate for each pipe size from this table in BTU per hour per linear feet. The first column is showing the pipe size and the second column is showing the heat loss rate in BTU per hour per linear feet for insulated pipe. As we are using insulated pipe, so we will select our heat loss rate value from here. If you are not using insulated pipe, then you need to select the heat loss rate from these three columns. If you are using steel pipe, then from here. If you are using brass pipe, then from this column, and for copper pipe type K from this column. As our pipe size start from 1 inch up to 4 inch, so we will select these values. For pipe segment between electric water heater and riser number 1, the pipe size is 4 inch and its length is 20 feet. And we have selected from the table for 4 inch pipe size, the heat loss rate is 46 BTU per hour per linear feet. So when we multiply this length 20 feet by 46, we get the total heat loss in this pipe segment equal to 920. Similarly, we have calculated the heat loss in all other pipe segment and the total heat loss in the main at the basement is equal to 10,300 BTU per hour. In the same way, we will calculate the heat loss in all the segment of all risers. For riser number 1, 5 and 6, these risers are typical. The heat loss for pipe segment of size 2.5 inch, the segment length is 208 and the pipe size 2.5 inch. The heat loss for 2.5 inch 32, so when we multiply this 208 by 32, the total heat loss for this pipe segment is 6,656. Similarly, for 2 inch pipe size, heat loss 924, for 1.5 inch 550, for 1.25 189. Then the total heat loss in each of this pipe riser is 8,319 BTU per hour. So in the same way we have calculated the heat loss in each riser in BTU per hour. Now we will calculate the GPM required to overcome heat loss in each pipe segment. We have the formula for GPM. GPM equal to BTU per hour divided by delta T into 500. Delta T is the difference of hot water temperature in degree Fahrenheit coming from the electric water heater, and the acceptable temperature is the last fixture. Assume the acceptable temperature for the last fixture is 120 degree Fahrenheit and the electric water heater is supplying hot water at 140 degree Fahrenheit, then the value for the delta T will be 20 degree Fahrenheit. So when we apply our calculated value for heat loss in each pipe segment in this formula, we get the result for GPM. Here you can see these are the GPM in each pipe segment of the main, and the total GPM required for the main is 1.03. Here you can see the GPM required to overcome the heat loss in each of riser 1, 5 and 6 is 0.8319, for riser 4 0.5535, for each riser from 7, 8, 9, 10 is 0.8077, and for each riser from riser number 2, 3 and 11 is 0.7868, for riser 12 it is 0.619, and for each riser from 13, 14 is 0.7106. So in this way we have calculated the total GPM required for hot water recirculation pump is 11.71, or for round figure we can take it as 12 GPM. Now for pump head calculation, first we will calculate the developed length. We will consider the total developed length for head calculation from the last riser. It will start from here and it will go along the main at the basement up to the electric water heater. Each riser height is 272 feet and the length of main at the basement is 275. So the total developed length will be equal to 275 plus 272 equal to 575. Now we will add 10% as compensation for fittings and walls to the total piping length. As these are risers, so we will not need more fittings, so we will take only 10%. Then the equivalent length will be total developed length plus 10% of total developed length, and it will be equal to 602 feet. Assuming pipe sizing at uniform friction rate of 4 feet per 100 feet, then the total pressure drop in the line will be equal to 24.08 feet. Adding 5% to the GPM and 10% to the head loss as safety factor, then we have selected our hot water recirculation pump with GPM 12.30 at the rate of 26.48 feet of water head. For hot water recirculation piping network, the GPM required for the last riser, that is riser number 14, is equal to 0.7106, and the GPM in the last segment, that is the segment before last riser, is equal to 0.7806. This value is the sum of the GPM of last riser plus the GPM required to overcome the heat loss in this pipe segment. Similarly, the GPM required for the pipe segment before last two risers, riser number 14 and riser number 13, will be equal to the sum of GPM for riser number 14 plus the GPM for riser number 13 plus the GPM for pipe segment A and plus the GPM required for pipe segment B, and its value we have calculated is equal to 1.5552 GPM. Now we have calculated the GPM required in each pipe segment of the hot water recirculation piping network. The maximum GPM in each riser is 0.8319 and the GPM in the pipe segment at main at the basement just before the last riser is 0.7806, and the GPM in the pipe segment of main before last two riser is 1.552. Similarly, we have calculated the GPM required for each pipe segment in the main and the basement, and we have tabulated here. Now we will use the hydraulic table to select the pipe size corresponding to these calculated GPM. This hydraulic table is for half-inch pipe size. For our return piping we will use copper pipe type K, so we will select this column, and we will not select our piping beyond 4 feet loss, this column for velocity and this is head loss. So we will not go in this row, we will select our pipe from only these top 3 rows. So for the pipe segment having GPM value up to 1.5, we will select the pipe size half inch. Then we will go next pipe size 3/4 inch. We will select the column for top copper pipe type K, and we will see here our limit for the head loss 4, so we will select only 2 rows from here. So we will select the 3/4 inch pipe size up to the flow for GPM. So for pipe segment having GPM from 1.5 up to 4, we have selected 3/4 inch pipe size. Then we will go next pipe size, that is 1 inch. Let us select the copper pipe type K, and let us see it is the 4 pressure head loss 4, it is our limit, so we can select our pipe size up to this row. You can see here the maximum GPM value is 10. So for pipe segment having GPM value from 4 up to 10, we will select the pipe size 1 inch. Then the next pipe size is 1.25 inch. Let us select the copper pipe type K, and our maximum limit for head loss is 4 feet per 100 feet. So we can select from here up to 15 GPM. So up to 15 GPM we can use the pipe size 1.25 inch. So for pipe segment having GPM value 10 and above, we have selected pipe size 1.25 inch. Thank you very much. So in this way you can design the hot water recirculation system for any high-rise building. After selecting the pipe size for each pipe segment, then you can calculate the actual pressure head required for hot water recirculation pump.